So good morning. My name is Prasanna Deshpande. Working with MathWorks, the makers of MATLAB and Simulink. Today I'm here to talk to you about, of course, electrification. And before getting started, I would like to thank Mr. Sheetal Kumar Joshi for setting the stage really well for simulation and virtualization for electrification. So I'm here today to talk to you about So electrification is mainstream nowadays. So every automobile manufacturer, almost every automobile manufacturer in the world has an electric vehicle either in prototype stage or in production stage or somewhere in between. MathWorks has been a part of this journey with many of these EV leaders, and while we worked with them, we have also gathered some good experience of what makes them successful. So here in this short time, I would like to present to you 8 stories uncovering focus areas of EV leaders. The format of this short presentation is going to be like, focus area will be on the left side of the slide, solution will be on the right side, and the actual story will be another separate slide. With these 8 stories, let's get into it right away. Range optimization, one of many important things for OEMs. Why? The survey from JD Power, that's basically EV Owner Satisfaction Ranking Survey. The left-hand side, I'll quickly read it out to you. Tesla Model 3 is has earned most satisfaction rating in premium battery electric vehicles, and Kia Niro EV has earned in the mass market electric vehicles. What is important is key findings from the study. One of the most important factors is range satisfaction. That's a key purchase decision for EV purchasers. And that is why it is very important for OEMs to do range simulation or range optimization. Now, in terms of tool, what makes OEM's job very easy is you need a vehicle level simulation model which is readily available and customizable. You don't have to start from scratch. You should have something pre-built. You should be able to quickly customize the architecture of the vehicle. The model needs to be open, so you should be quickly able to parameterize the model. The model should be able to run fast because you're planning to do optimization. The model will be run thousands of times. And most importantly, with your simulation platform, you need to have attached optimization capability because we are talking about range optimization. We are talking about component sizing and its effect onto the vehicle range. If you have this kind of tooling, it is definitely going to help optimize range and reduce time. Who has done it? The real story? Tesla. Tesla have been using model-based design since 2008 for their Roadster vehicle as well. The main thing with Tesla is that, okay, I'll quickly tell you one story about it. They used motor control, model-based design for doing motor control, and they improved their motor efficiency by 6 to 8%. And that helped them to increase overall vehicle efficiency by 15 to 18%. This is how Tesla beats nearly everyone in the range game. Want to read more about it? There is that link onto that public article done by Tesla. Let's go to the next very important challenge, thermal management. I don't think we have to discuss why thermal management is important. As far as modeling batteries is concerned, as leaders of different teams responsible for building different products, you will find need for building multiple fidelity models, even for thermal simulation. While you are doing battery design, what is important is cell level battery model, which is electrical as well as thermal. So I have thermal characteristic of every battery cell represented. Everything, when it is connected together in series and parallel, you get a pack where thermal characteristic of each and every cell is there. That is one way of doing it. Another way of doing it, while designing, when you are validating it, it's not necessary to get into that level of detail. That is where you can go ahead with a battery pack level thermal model, or you can go ahead with a equivalent circuit based model. So there are multiple fidelities. You need a totally different fidelity when it comes to do BMS validation or HIL validation. So that's basically thermal model. So what is the solution? Capability to build fidelity of battery model at different stages of development. And it's not just good working cases. What is more important is being able to simulate the fault cases. Like the graphic shows thermal runaway simulation. These are the scenarios which we definitely want to simulate and make our controllers, our battery management systems robust against. This also has a link with range simulation because you need to analyze the impact of thermal runaway, impact of temperature onto your overall vehicle's range. Who's done it well? I would like to talk to you about Mahindra Electric. My friend Vipin at Mahindra Electric, he created and validated system level simulation model for electric vehicle with battery, cooling circuit, refrigeration circuit, vehicle and driver. He could get away by using 1D simulation for building the battery thermal management system. Again, you can later on get into details of this. The next point is on data-driven engineering. Now the challenge here is, there are domain engineers, like most of you, who understand the domain, but maybe you struggle with handling large amounts of data. Maybe you struggle with doing AI modeling, because you are probably not good scripters. And on the other hand, there are data scientists who are really good with data handling and AI modeling, but they probably fail to make sense out of data because that requires insights from the domain. So what you need as a solution is you need a complete AI workflow which helps you to, which supports different use cases like battery analytics, remaining useful life prediction, digital twins, and predictive maintenance. So again, what is that full AI workflow, complete AI workflow? It's basically about data preparation, AI modeling, simulation, and deployment. It could be onto embedded platforms, it could be onto cloud, or it could be onto an edge device. Again, having this data-driven workflow also helps you to take this AI model back to your vehicle model, back to your simulation model, integrate it as a part of it, and simulate it. Who has done it well? Neo Car Company. Now, their challenge was they had large amount of data that was required for developing battery SOH prediction algorithm, which was a cloud-based architecture. Initially, they did not have a lot of data, so they built simulation models. They used synthesized data for initial algorithm, and as they started getting data from field, they updated their algorithms. That's a very interesting use case for them. Let's go to the next point, which is OEM supply relationship. The technology disruption has been driving two important requirements. Standards such as AUTOSAR, which are helpful for OEMs and different suppliers to share their software components with each other. And second requirement is very similar on modeling side. Simulation integration platforms, which are helpful for, again, OEMs to share different models built by different suppliers so that they can do virtual validation. The solution there is, for example, Simulink. It supports the AUTOSAR workflows. You can integrate, you can simplify AUTOSAR application software development by using Simulink, and at the same time, MathWorks has been heavily investing into developing Simulink as a simulation integration platform. See, we understand that different suppliers will be using different simulation softwares, but you need one simulation integration package which helps you to connect with different tools. And that is what today Simulink integrates with more than 150 third-party tools on a co-simulation basis. Who's done it well? Volvo for their XC90. This is a very impressive story. Look at that sentence. ECU platform independence is what Volvo could achieve by building multi-domain simulation models and by nudging their suppliers to go on AUTOSAR platform. I'm also going to talk about one of the suppliers of Volvo. That's my next example. That's about functional safety and compliance. So, functional safety is integral part of automotive development, and ISO 26262 defines the complete development process for E&E systems, electrical electronic systems. So what do we mean by complete development process? Requirement specification, design, implementation, integration, verification, validation. So it's about having the complete process. The solution is one needs to use ISO 26262 compliant development process as well as qualified toolchain. Once you set this toolchain, it becomes really easy for you to, as a supplier, to deliver your software to the OEM. And that is the example which LG Chem proven. LG Chem was BMS supplier for Volvo for their XC90. They did AUTOSAR plus ISO 26262 compliant software generation for their BMS. AUTOSAR was required by their customer, by Volvo, and ISO 26262 process was their own passion. That is how they could achieve a lot of reuse. Also look at the quality. Their software issues reduced from 22 to less than 9 per release. So that's what it speaks about. process, having a set process for software development. Next is about efficiency in software development. See, I spoke about AutoSAR, like software sharing. Then I spoke about process, ISO 26262, functional safety. How do you put it all together? Because now we are getting into software-defined vehicle era. Software content in the vehicle is exploding. How do we cope up with the complexity? The solution is to adopt best-in-class software development process to drive efficiency. This is where I have to talk about MathWorks. MathWorks Consulting Services has developed an offering called as process assessment. It helps you to, we basically analyze your process, your software development process, be it manual or be it model-based design process, and we come back to you with a recommendation of what delta changes can you make to your process to make you meet your quality standards, or it could be ISO 26262 or any V&V standard that you may have. Next is, industry now is heavily investing into skilling their workforce. We are talking with, I say this because the number of trainings we have been doing for multiple organizations based on electrification have increased in last 2 years like anything. So we do have electrification based trainings, and a lot of organizations are reskilling their workforce. Basically, the engines and powertrain people are now getting redirected towards electrification projects. And second point here is, for new workforce, a lot of companies are working with academia to develop joint curriculums, to collaborate with them and come up with something which helps students to bridge the gap, to reduce the ramp-up time of students once they become professionals and join companies. One such collaboration to talk about is, the slide cannot be read, but I can say it here. Bosch and NIT Calicut collaborated with each other, and MathWorks helped them to develop a curriculum for system engineering for electric vehicles. And now that is rolled out really well. Initially, MathWorks and Bosch delivered few sessions. Now the faculties are ramped up, and now they are churning out about 250, as an elective subject, about 250 people are taking this course. This is just one of many collaborations that we have been doing, or industry has been doing. The last point is about beyond the drivetrain. So it's not just about the vehicle, we all understand. It's also about getting from vehicle to grid. It's all about infrastructure as well. However, we don't have experience of just working in automotive industry. We also work in little outside of automotive. Would like to take your attention to one such project, which is Toyota City project. I'm not sure if you are aware about this. This was a 2-year project done in Japan about low carbon homes. In this case, each house generated its power with fuel cell and solar panels. They had a battery and they stored that power in that battery. They actually sold power to the grid when the grid needed power, and they bought power from the grid when the power rates were low. Every vehicle, every home also had an electric vehicle. So that acted as a supplemental battery storage. That battery storage could be used for powering up the home when electricity prices are high. Or, of course, you also need to have a feel of when you want to go out and what is that battery charge that will be needed for you to come back home. So all that, so that was a large project. Unfortunately, I don't have a link which relates to MathWorks about this. However, go on Google, Toyota City project, you will find a lot of interesting details. Understand that this acts like a microgrid. So this is like simulating a microgrid using different tools. And that's what wanted to highlight slightly different aspects of V2G here. So to summarize, we spoke about 8 stories uncovering focus areas of EV leaders. There is a lot of information onto my slides. The slide deck has links to original stories, as well as there is a lot more information if you are interested. My request to you, our time here was short. If you reach out to me, LinkedIn or email, we'll be happy to share slides with you. We'll be happy to have more conversations with you. Thank you for your time.